Hey guys, this is Isa, here to help you guys on your journey to programming. Again, we're on the road today, so I wanted to jump in and add to the series by starting up a new talk, which I'm going to begin trying to do either weekly or bi-weekly. The idea is I want to be able to talk about simplifying the learning process for game development by breaking down tasks and mechanics into bite-sized pieces that beginners can really jump into and begin implementing. I know this is going to be a podcast, so I don't want to break too much code or break down into too much code. Instead, I want to talk at a high level to get your gears kind of moving and allow you to think about how you can go about making a mechanic or an overall arching game by breaking it down to the simpler steps. What I found is a lot of my students and colleagues, especially the more entry-level colleagues and students, they find it difficult to break down a complex task and begin working on it. A lot of the time they'll be given a task and hours, days will go by and minimal progress will be done. And the reason ends up being that they're just a little bit lost. They have a difficult time breaking it down and thinking about it in little steps. So that's what we're going to begin doing, and I want to try making this a regular podcast. So if you are interested in hearing this kind of a podcast theme and topic, then please do subscribe to Journey to Programming, the blog, and our website. The website can be found at www.journeytoprogramming.com, and our blog can be found directly on our website. We should be on iTunes as well as BeyondPod and Google. So, without further ado, let's go ahead and kind of jump into this. So for a lot of you guys out there, you may be wondering, okay, you're a beginner, you want to learn how to program, and you want to begin to make games. And games are very complex. Even a simple game has so many different layers to it that even it has a high level of complexity in comparison to a very linear made interactive or application. And that could be because there's game loops going on, there's game managers to determine whether you are actually getting a score or you're getting a win-loss state, and all of these different functionalities. And then you have the logic behind it. Do you want to actually have game logic in your application that's changing and being dynamic? And that's when you begin breaking into artificial intelligence's influence in games and how state machines work. But let's go ahead and start out really, really small. And let's talk about just prototyping. So let's just really quickly talk about how would we prototype a really simple 2D side-scrolling platformer, okay? And we probably won't have enough time for this on-the-road podcast, so we may break this down into 2 or 3 episodes. But when talking about a side-scrolling platformer, a lot of the mechanics are fairly simple to think about. You have movement. You should be able to move left, right. You have usually an ability to jump and then fall. So those are kind of the core mechanics. In between there, you may have some animations that are triggering based on the direction that you're heading or the arrow direction that you're pointing. If you're pointing downwards in a game like Classic Mario, you duck and you hold your head, and then when you're jumping, you kind of break into another animation. Each one of those also does have a different mechanic to it in the form of, in some 2D scrolling platformers, you can't kill somebody or you can't defeat them when just walking into them on the horizontal axis. You have to be falling downwards while making contact with their collision box in order for you to actually be attacking them. And that is by design. But let's not break into that. Let's just talk about how do we prototype this. So I would begin, even if we're making a 2D platformer like Mario, where we can jump on platforms, we have enemies that move around and maybe fire shells at us here and there, or fireballs. I would begin at the most primitive functionality. And if you're using something like Unity, you can begin doing this pretty quickly. Unreal as well. You can begin working on this with blueprints if you are kind of well versed with it. But where I would begin working is, the first thing I would do is I would probably make an empty scene, and I'd begin working on my player prefab or my player game object or actor. And the big thing there is I want to be able to make an object, and I want the code to already behave in a rough way that's like what the production version should be doing, just so we can begin really testing it, getting a feel for, are these the mechanics we want? And if they are in this rough stage, how can we polish them to really make them good? So I would begin working on that first player, or that player object and the script associated with it. In Unity, what I would do is I'd make an empty scene. I would probably start off with a cube, just a regular 3D cube or a 2D cube, or a 2D box, I guess. And then I would add a script to it, and I would begin prototyping functionality in the script. One of the ways to do that, especially in Unity, is you can go ahead and add a script, and then you could very, very quickly and dirty add in your update loop some detection to determine if you're trying to move your character. Okay? So you've now created an empty scene, and you've added a box. When you press play, if your engine or whatever platform you're using has gravity, your box should just continue falling. So we need some sort of ground platform so that he doesn't fall through. Add a ground platform in there. But then let's think about primarily this core functionality, because we're going to try making this right now, just at a kind of a high level. So I want to add the movement functionality to my player. I need to, in my update loop or my tick loop, in some way or manner, I need to detect whether or not I'm telling the player to move. In Unity, you can use the, I think it's input.getKeyDown, which would get you keyboard input, right? That's great. If we can get keyboard input, then we can handle it as necessary. If we want, we can also use something like input.getAxis, which is an API that's also really good, because that allows us to automatically begin using multiple forms of input. So Unity provides that functionality where we could say input.getAxis, horizontal axis, and what that'll do is it'll take the input that's mapped to be on the horizontal axis, which could be the keyboard, or it's already set up to work with a joystick, like an Xbox 360 controller, and it will begin pushing that input from those devices into your software, which is great. That just kind of simplifies a lot of the complexity in getting the input to read in from different joysticks and COM ports and stuff like that. So that's how I would begin handling input. Now, as you begin reading this input, you need to begin applying it to your character. Okay, so these are the steps that we need to take. We need to receive input. One way you can test that you're receiving input, you can go ahead and read that input into a variable and print out the variable. Every time you press a key or move a joystick, analog stick, or the actual D-pad, you should see some sort of raw input being received. A lot of the times it's going to be a value between 1 and -1. And that's going to stand -1 for moving left, 1 for moving right. All right. Now, taking that data is the next step you guys need to handle. So once you've confirmed you're receiving data, you need to handle it. And by handling it, I mean you need to apply it to your character so that when your input says that you're moving on the horizontal axis at a rate of 1, your character object begins moving to the right in your screen space accordingly. So you need to apply that data to the transform or the XY coordinates of your character or your object in the prototype scene. That would be the next step, okay? You would then want to apply it to your vertical if you need to, If you have something where you're moving forward or backwards, you definitely want to apply it there. If you're going to be applying it for a jump, then we may want to consider what type of input we want to receive here. So if you want to jump, usually that's performed on a button. So you may want to consider using something like input.getKeyDown and use a space bar, or you may want to actually read input from a joystick. Perhaps you want to read input from a Xbox 360 controller and feed that into your jump. So again, you want to go through the same prototyping. You want to go ahead and set up your code so that it reads input, confirm that you're reading input by either doing a print log or watching the data change while actually following the code in debug and breakpointing stuff where it should be called. And then once you've confirmed that you're receiving the data and you're comfortable with input now, you want to go ahead and apply that to your object, okay? Apply it to your object, and in this way, or in this attempt, you're going to want to make your object jump. So you're going to need to move upwards on the vertical axis, and this means that if you want gravity to be applied and bring them back down to the floor, you need some kind of code to handle that too. So now we get into some other complexities, which in Unity could be as simple as, okay, we want to maybe start using the physics engine. And instead of detecting and modifying the transform of my object, detecting input and modifying the transform, maybe I'll detect input and use the physics engine to move my character and also apply a jump. The reason that may be an option in Unity is because Unity's physics engine will allow you to apply gravity, which will bring your player object back down to a ground level that you've set. So that may be a way to simplify this, but in the beginning, I would just say detect the input and apply a jump manually. If you want, go ahead and hard code an offset in the vertical and apply that to your object. And you may see your object just kind of flash to a higher level. You're not going to see it nicely kind of interpolate between them or nicely ease on a linear curve upwards, but you'll at least get to see that input's occurring. The result is your player moves up, maybe like 4 units or something like that, and then you want to be able to handle the gravity. And the only reason I'm saying make it really simple right now is because I don't want you to get stuck. I don't want you to be lost yet. I want you to focus on a goal and get it to work. Once you've got it to work, you'll realize, okay, in my real game, I can't have my player just flash, like teleport from the ground level up to that next platform. I want them to be able to ease up there on like a nice curve to get on that second level, just like Mario does in a platformer, okay? So then you're going to want to change that. You could write your own hard code, or not your own hard code, your own version of the physics engine and modify it so it actually follows a curve, and you modify the transform accordingly. Or if you're using a game engine like Unreal or Unity, you can actually use their built-in physics engines. You'll need to change the way you're setting things up a little bit, but those are all options. Okay? So now, if you've gone through this, what you've done is you've prototyped a player that can move around, left, right, potentially jump as well. We haven't done anything with moving downwards because in a game like Mario, all the down button does is allows him to duck. So if you want to put a placeholder in your code, you can. You can go ahead and do a check to see if the player is holding the down arrow or the analog stick pointing it downwards. And if they are, just put a print statement in there for now, or put a comment and say to be implemented when we want to add a mechanic for our player when they're holding downwards. And that at least gives you the kind of the comfort that something's there as a placeholder for the future. All right. After that, there's a lot more to begin touching on, but for right now, you've got basic movement, and that's where I'm going to want to keep us on this episode. So once you've gotten that basic movement down, I really do encourage you to take the next steps. Try adding a platform in your scene and see if you can get your cube object or your player object to get on top of that platform. All right. If you're using a game engine, this is going to be a little bit simpler than if you're kind of doing an intense learning process, learning how to write games in like a graphics rendering pipeline. And I don't necessarily recommend one or the other. I think whatever you want to do is great. But I expect a lot of you guys are going to be learning on game engines. So I really do encourage you to try and take that next step. And then once you have tried, go ahead and push on to the next episode. Again, this was Issa. I'm helping you guys on your journey to programming. This was an on-the-road episode, and I hope you guys like it. Have a good one.